Okay, good evening everyone. It's just finished raining, so perfect conditions to give a geo video. I just wanted to share a bit about this weather station that I've got at home. I know that you have already done climate in the first term, but this will help to confirm a lot of the things that we've done in class. Alright, so this weather station, I set it up, it's running off a Raspberry Pi. There's 3 sensors on it, and it's situated kind of under the roof outside, and it creates these nice graphs, which we'll go through individually, and just see if some of the concepts we learned kind of become clearer to you. Okay, so the first graph we'll look at is from today. This is the temperature versus relative humidity graph, and the blue line is the relative humidity, and then the yellow line is the temperature. And you can see today the lowest temperature was just before, a few hours before sunrise, so at 4 o'clock, that's when the temperature was at its lowest, and the temperature got to its maximum at about just before 4 o'clock in the afternoon. So if you then compare that with the relative humidity, it shows you that when the temperature was very low, when the air temperature was very low, the relative humidity, the blue line, is very high. And when the temperature gets very high, then the relative humidity is extremely low. So that's what you would call an inversely proportional relationship, where the one is high and the other is low, and vice versa. The reason for that, as we have learnt, is that when air is very warm, as you can see at about 4 o'clock today, when the air gets very hot, it can hold a lot more water molecules, water vapor, and that means the relative humidity, the amount of humidity that you feel, is very low. When the temperature is very cold, like this morning, at just before about 4 o'clock in the morning, then the air molecules were very close together and could not now hold a lot of the water vapor, so there was more humidity to be felt. So the relative humidity, we would say, would be high. And you can see what's happening now is, as the temperature's dropping very quickly after the sun has set, the temperature's going down very rapidly. And now if we can refresh this, and you will see it should, it adds the other data points here. As we approach 8 o'clock, you'll see that the relative humidity is getting up to like 90% relative humidity. Obviously it's just rained now as well, so there's a lot of water vapor sitting around, but that correlates with this very low air temperature at the bottom here as well. So it's now about 17 degrees. That's the temperature and relative humidity relationship. If you look at that, say, from the last 7 days, which this hasn't been on yet for 7 days, it's only been on for about 4 days, then you can see that this relationship is true for every day that we have. So you'll see in the middle of the day you have these big peaks of high temperatures that usually occur like 4 o'clock. That was at 2:30, like in the afternoon, and this was at 20 to 4. And those big peaks of high temperature during the day correspond to these very low troughs of relative humidity. So in the middle of the day when it's very hot, then the relative humidity is really low. And at night when the temperature is very high, at night when it's low, then the relative humidity gets high. And that's also, you will notice that in the mornings now there's a lot of condensation on the ground, there's a lot of dew, there's condensation on your car roof if that's outside, and that's because there's just a lot of water vapor in the air because of this high relative humidity. So if we move on now, we'll go back to just looking at today's case. You can see it's a mirror image, like this will peak at about 20 past 11, when the temperature just peaked a small bit. It corresponds to this little dip in the relative humidity as well. Relative humidity dropped a bit. If we go to now look at the second graph, this is the pressure and temperature relationship. You will see that, so the temperature is the yellow line again, and pressure is the red line. There's 2 things to notice. The first is that the air pressure does not change that much during the day. There's not these massive swings, And you'll see the difference between the highest and lowest pressure today was like 3 hectopascals. So the max was 846 and the minimum was 843. Um, so would barely be a different isobar line on a synoptic chart. But you can still see some relationships. So the first relationship is obviously when the temperature is very high, the air is very warm, then the air pressure drops. And that we know is because when you've got warm air, the warm air rises, which results in a low pressure forming at the surface. And that's what you find at the equator, that's what you find at at the polar front, is when you've got higher temperatures, you get low air pressures. And the reverse is true for air temperature, where air temperature gets cold. Like this morning, when it was still, sun was just rising, you can see there was a big spike in air pressure. So the air was actually still subsiding all the way until 10, 11 o'clock, when it gets to about 24 degrees, and then the pressure starts going down quite rapidly. So once the air gets very warm, then the pressure can drop. Once it starts rising, then the pressure drops quite rapidly. And now you can see as the sun went down, just at about 6 o'clock, then you can see how the temperature went down, and now the air pressure is going up, because the air is subsiding again once the sun goes down. And if you look at this graph over, say, the last 7 days, then you will see the same kind of relationships, where at night, when the temperatures get low, the air pressure has these spikes, and it's almost like there's a lag. So there's a bit of a lag of, say, like an hour or two between when the air is very cold and when the air pressure is actually at its maximum. So that's obviously because the air is actually still cooling down, and the air takes a while to heat up. So the air is actually still very cold by 16 degrees by the time that the sun is already up. And you can see then, again, this is over the last 4 days, so each of the peaks of temperature show you when that was kind of midday, or when the sun was heating up the air to its max. So you can tell even from this graph that when the air was very hot, then the pressure dropped. And the next day you can see when air temperature was high, the pressure dropped. And the next day, the same relationship happened. You also see there's a lag between where the air temperature was very low before sunrise, and then 2 hours later, the air pressure spikes. And you can see that on all the days. It's quite cool. You can see every day, about 2-3 hours after sunrise, the air is actually still cold, and it's still subsiding. Okay, then we'll just go back to today so far. Then for the last graph, this is just a relationship between pressure and humidity. This kind of shows you that from this you can see when there was midday. You can see that when the air temperature goes down, then air pressure and relative humidity also go down. And then as soon as the sun sets, just at about 5:45, the relative humidity and the air pressure start to shoot up. And now we're sitting at quite a high. It's like 90% relative humidity, and the air pressure is at its highest during the day. And if we look at this for the last 7 days, you will see a similar relationship of so these very low troughs of relative humidity are actually during the hottest part of the day. So you can see every time the relative humidity goes down, then the air pressure is down, and they kind of follow they're vaguely related, although there are slightly different kind of relationships going on with the temperature as well. But you can see there are these fairly good relationships between the peaks and the troughs in the relative humidity and pressure. And if you take it back to today, yeah, that's been my weather station, so I will leave it running. And what you will notice is that as we get to winter, if you look at the past 7 days, when you get to winter, as we approach probably further into May and June, you will slowly see the maximum temperature start to get lower, almost day by day. And it won't get lower by much, but you'll start seeing these peaks of high air temperature start getting lower and lower and lower. And you will also see, so it means it will be colder and colder during the day, and then the troughs of the temperature where it gets very low, you will see um, that getting lower as well. So like now at night, last night it was 17 degrees. That's not that cold, but as we get onto winter, you'll start seeing that temperature at night dropping and dropping and dropping. And as the sun rises um, later and sets earlier, you will see that the time of day when it's coldest and warmest actually changes a lot as well. And then we'll keep an eye on that as well as the developments change. So hopefully that helped you a bit to see the relationship. But the key relationship here is that um, when it's very hot, then the relative humidity is super low. And the other one is also when it's very cold, then the air pressure rises a lot. And when the air gets warm, then the air pressure drops, and that cycle continues day in and day out. Okay, thanks guys. See you next time.